Hello, my students. Our lesson today speak about the graduation of the properties of elements. Okay. At the end of our lesson today, we must know the four objects. Number one, determine the properties of some elements by knowing their atomic number. Number two, identify the metals, non-metals, and metalloid. Number three, compare between the properties of groups and the periods of the periodic table. Number four, identify the polarity of some chemical compounds. Okay, part one. Now we will study together the atomic size, the property. In our lesson today, we will speak about the property graduation of some properties of element in periodic table, especially in a group A. Number one, atomic size property. Number two, electronegativity property. Number three, metallic and non-metallic property. Let's study together the first one, which called the atomic size, the property. What is the meaning of atomic size property? Atomic size, if I know, or if I need to determine knowing the atomic size, we must know the meaning of atomic radius. What's the meaning of atomic radius? In math subject, if we draw the circle, and this is the center of the circle, if I need to know what is the meaning of radius. Yes, bravo. The meaning of radius, this is the distance between the center of the circle and the circumference of the circle. This distance is called radius. The same thing in atom. The atomic radius, which called the distance between, or the distance from the center of the nucleus and the outermost shell, or the energy level, but this is the mass containing electrons. This is called the atomic radius. If we know the atomic radius, then we can determine the atomic size of the atom. Okay, the measuring unit of atomic size, which called picometer. The picometer equal the part of million part of meter, which equal 1 times 10 power of minus 12 meter. This is the measuring unit of atomic size. Okay, let's watch the video about the atomic size.
Nucleus and outer electrons. The atomic radius increases down the group of transition elements. Reason? Because the number of shells increases in a group. Note: atomic radius of transition elements is less than atomic radius of between nucleus and outer electrons. Atomic radius increases.
Okay, after watching the video, during the video explaining the graduation of atomic size through the periodic table. Okay, let's watch, or let's speak about the periodic table. This is the periodic table. Okay, this is called period, bravo, and this direction, or this is column, it's called bravo, groups. When the atomic number increase from the left to right, the atomic size will be decrease in period. What about in group? In group, when the atomic number increase from up to down, the atomic size will be increase. This graduation of atomic size from the periodic table. Okay, I have a question. Why the atomic size decrease in the period from the left to right? The same thing in the group. Why the atomic size increase in the group from up to down? Why? Okay. Now I will explain why the atomic size in the same period will be decrease from the left to right. Focus on the direction of the decreasing of the atomic size from the left to right. Why? Because by increasing the atomic number in the same period, the attraction force between the positive nucleus and the outermost electrons will be increased. When by increasing the atomic number, which mean in the second period, lithium, beryllium, barium, carbon, neon, oxygen, fluorine, and so on, when increasing the atomic number, the attraction force between the nucleus inside the atom, which carries a positive charge, and the electron, which carry the negative charge, will be increased. Then the atomic size will be decreased. The size of the atom will be decreased in the period. Okay, what is the reason for the atomic size in the same group will be increased from up to down? The atomic size in groups increase from up to down in the same group. Why? Because by increasing the atomic number, the number of energy level occupied with electron will be increased. For example, if I need to make the electron distribution for the beryllium and magnesium. Beryllium, the atomic number with 4. An energy level carry, the first one carry the 2 electron and the second one carry the 2 electrons. What about the magnesium? 282. What about the calcium? 2882. What we will note? We will note when the atomic number increase, the energy level containing the electron will be increased. The beryllium which have the 2 energy level, magnesium 3, calcium 4, and so on. By increasing the atomic number in the same group, the number of energy level occupied with electron will be increased. Then the atomic size in the group will be increased. Okay, if I need to draw the relation between the atomic size and the atomic number in the period and in the group. Okay, the atomic size of element in the same period, I said before, that's inversely proportional to the atomic number. When the atomic number increase, the atomic size decrease, and vice versa. In the period. What about in a group? It's directly the atomic size is directly proportional to the atomic number. When the atomic number increase, the atomic size will be increased. When the atomic number decrease, the atomic size will be decreased. Right. I have a question. I need to know to say something in periodic table. Right or wrong? The atomic size in the same period from the right to left will be increased. This is wrong or right? Yes, bravo. This is right. I said before, you must focus the direction of the atomic size. I said before, the atomic size will be decreased from the left to right. But in the question, I I ask you about the atomic size will be increased from the right to left. Okay, let's continue. I have some notes in our lesson. Number 1, the element of group 1A is the largest atomic size in the modern periodic table. The cesium is the largest atomic size in the modern periodic table, which is located in S block, the first one, the first group. What about the fluorine? Fluorine is the smallest atomic size in modern periodic table. يبقى cesium largest atomic size and the fluorine is the smallest atomic size. Okay, at the end of this part, I hope you enjoy our lesson today, and I will continue in the next session, inshallah. Goodbye.